Can we just verify that everyone has SolidWorks and the setup with that?
Give a thumbs up, virtually or in person.
Version should not matter. Version basically only matters if you're sharing files. So as long as, because we're not sharing files right now, you're totally all right with 2010 if you wanted. Cool. Okay, so I guess just to introduce yourselves, those of you being run by the Yale Undergraduate Aerospace Association. We do lots of different projects every year. Rowan and I were the presidents last year, and Theo Evers, who is also here, is one of the current presidents. So what we're going to do today is basically try and run through the basics of SolidWorks. SolidWorks has like a super duper high ceiling. So we just want to kind of cover what the basics are, which will kind of be basically making parts and making assemblies. If people like Rowan and Antonio, if you guys ever want to jump in with stuff, please do. I'm going to go ahead and share my screen so we can just go over what we're making today.
And I just want to note while we're at it, if you guys have any questions at any time, like feel free to just drop a question in the chat and I will try and answer them as quickly as possible, even if it's something like, where was that button? Because sometimes you get really behind if you just kind of miss where someone clicked and you don't know where the menu is. So even if it's just a question of like, where was that button? Just drop in the chat and we will answer it.
Can you talk to them for a second, Rowan? Antonio,
Yeah.
I forgot to get my mouse set up.
But yeah, for context, Ian's got some really great plugins that are good for remote learning, so you can see exactly what he's clicking at all times. And yeah, if you're, again, if not everybody thumbs up that they had SolidWorks, so if you're just coming in or you're having trouble getting SolidWorks, just shoot us a message and we'd be happy to help you. And also Sarm Abbas just joined. Sarm is the other design fellow at the CEID. Sarm is also a great resource to ask questions if you need it. Did that stall for enough time, Ian?
I need like 30 more seconds.
Yeah, so while Ian's getting this up, like he mentioned, and just to kind of reiterate with this, SolidWorks is actually, it tends to be a pretty user-friendly software. The biggest barrier to entry is getting started. So being here and doing this today is kind of the best way to get into this. So the way that this is structured is really teaching you all of the basic functions. So how to make a sketch, how to do an extrude, you know, how to do all of these basic functions that you're going to use a lot. And then from there, getting better at SolidWorks is going to be a lot about just making something. So top recommendation moving forward once you're finished with this workshop is like find a project online that you're excited about that's like somewhat simple and try and CAD that, and it doesn't need to be perfect. But that's the best way that you're going to keep going. But what this is structured to do is to give you the basics, help you get used to like navigating menus, because sometimes it's a matter of, I know what I want to do and I know that it can do it, but I don't know where the function is. So this is just kind of getting you to get the groundwork, and then you can work from there, and Google will be your best friend from there as well.
Okay, so we're ready now. So I have a little attachment that if you see in this upper right-hand corner is my mouse. So if I left click, you'll see it red, right click there, and then the scroll key, if I hold down, it'll show up on green.
Wait, can I ask a quick question?
Yep.
So like, what is the, like when I am trying to make something for like 3D printing, like if I have a choice between MakerBot, like the printing software thing, or SolidWorks, what is better for like what situation?
Yeah, so that's like great. So we'll get into that. But in short, SolidWorks is a CAD software where you design components and you can export those components in many different file types. MakerBot software is not a design software, but it's a printing software, a slicer. So it takes a certain type of exported file called an STL, and then slices that and puts it in a format which the 3D printers can take.
Got it.
Yeah, so this is a little overview about SolidWorks. So yeah, if anybody has any questions, like please, I would love it if you just interjected at any point in time. But what we're gonna start off with is just kind of going first off what we're gonna make, and then a little bit about like the SolidWorks interface. So what we're seeing right now is just the rocket that we're planning to make. It basically has 3 really simple parts. we have a nose cone, a top body tube, and this bottom body tube. So what we're going to do is we're going to start this with the simplest component, which is this middle blue body tube. Then we're going to do the nose cone. And then to go into a little bit of like some modeling with SolidWorks, we're going to do this more complex bottom piece. So this rocket is not similar to how we would design one to fly, but it'll like have some of the features, and the main thing is it'll show you kind of like some of how to work with SolidWorks. So I guess to start off, what we're going to do is we're going to create a new part. So SolidWorks has parts and assemblies. Assemblies are just basically what you can think of it as an assembly of different parts. So right now in my rocket assembly, I have these three parts: a bottom tube, nose cone, and top tube. So again, we're going to start off by making a new part, which is the top tube. So what I'm going to do is you can either hit File and go to New, or you can click this little piece of paper right here. So once you hit that new SolidWorks document, what you're going to want to click on is Part. And then we can click OK. And then we're in a new SolidWorks document. So basically SolidWorks, everything that we do with 3D modeling, all like starts with this idea that we're starting with 2D, and then we're moving to 3D. So the simplest like way to think about that is that what we're going to do is we're going to first start out with sketches, which are two-dimensional. So if you wanted to make, let's say, a cube, what you could do is you could start off with a square and then extrude that square into like a three-dimensional state. So just to start us off, I think what we're going to do is we're just going to first create a new sketch. So up here on the left-hand side, you have feature, sketch, and all of these other stuff. Really, the things that we're going to be focusing on today are just sketch and features. So to create a new sketch, I'm going to click on the Sketch tab, and then click on Sketch. And then anytime we create a new sketch, it's always going to ask us what like flat surface we want to make a sketch on. So you can click on any of these three planes: front plane, top plane, right plane. I'm going to go ahead and click on the front plane. So right now, you should just be in sketch mode. And the way we know we're in sketch mode is if we look at the upper left-hand corner, you'll see this button that says Exit Sketch that's in gray. So that means we're in a sketch. And up over here are all of our different tools that we can use to sketch with. So we're just gonna mess around with sketching just to start us off. So let's go ahead and click on square or rectangle. And if you notice, we can click anywhere and make a square. And then let's click on circle, and you can notice we can make like all these different shapes. So there's hexagons, all kinds of stuff. But let's start off and let's just make a really simple cube. So what I'm going to do is I'm going to click on the rectangle, and our goal is to make a cube that's 6 by 6 by 6 inches. So I clicked on the rectangle button, and then I'm going to click anywhere and then extend it out. And there. So now we've made a rectangle. If you notice, I'm still actually in the rectangle mode. So if I were to click in another spot, I would make another rectangle. So and what we're going to do is you can either hit the escape button, and you notice now we're no longer in rectangle mode, or you could just click the escape button or click the rectangle button again. So you notice nothing else. So what's now fun is we can click any of these quarters in the sketch and drag this around to different sizes in order to change its size. So if we actually want to constrain this rectangle to like the actual dimensions of a square though, what we're going to want to do is dimension the part. So the way we dimension a sketch in SolidWorks is using something called Smart Dimension. So in the upper left-hand corner, next to the Exit Sketch button, there's this button called Smart Dimension. I'm going to click on that. So smart dimension in SolidWorks is really nice because it's smart. So if I click on one of these lines, you'll see that it lights up when I hover over it, and I click on that line. Smart dimension knows that I probably want to dimension that line. So if I click on that line, then left click one more time, it's going to create a smart dimension for that line, and this little pop-up will appear. So once this little pop-up appears, I can put any dimension I want in there. And let's say, again, we want to make a 6 by 6 inch cube. So let's make that 6 inches. Great. So you see that line is 6 inches. So now we want to make this other side 6 inches so we can make that cube. So I'm going to go ahead, and I'm still in smart dimension mode because the smart dimension button is in gray. I'm going to click the other side, click once, and then click again. And then the little pop-up box occurs. And again, I'm going to enter 6 and press enter. Great. So now we have the 6 by 6 inch box. So I'm going to go ahead and exit smart dimension by pressing the escape button or by clicking on smart dimension. But if you notice, I can still take this and drag this guy around. So anytime we have a sketch, we want to have something where it's fully constrained. Basically, it's the idea that once it's like fully constrained, such that if I were to go back and try and edit this, I wouldn't accidentally try and make any changes. So the way I'm going to do that is I'm going to just click on any of these corners. I'm going to constrain it relative to the origin, which is this little red 2 arrows here. So if I hold down one of the corners and drag it over to the origin, it's going to constrain the corner of this rectangle to the origin. And now if I try and drag this rectangle anywhere else, it's not going to move. If you notice, the lines are now black instead of blue, which means that this shape is fully constrained. Can I get a thumbs up once everybody kind of has that? Cool. Okay, fantastic. Again, if you ever have any trouble, just like pause and like ask. So what we're now going to do is we're going to exit the sketch.
So I'm sorry, when I dragged the corner to the origin, it didn't constrain. Does like snap to point or something have to be on?
Honestly, like it's not really important for what we're doing right now. So I would just go ahead and move on.
I think there's a question in the chat.
Oop.
How would you move the constraint?
That's a great question. So at this point in time, this is one of the really incredible features about modern CAD software is that you can always go back and make changes. So if I want to go back and change my sketch, I'm going to go to this toolbar on the left-hand side. And if I right-click Sketch 1, this little pop-up is going to appear. And in the top left-hand corner of that pop-up, there's a little button that says Edit Sketch with a pencil on it. And I'm going to go ahead and click on that. So now if we notice, we're back in sketch mode. And we know that because there's an Exit Sketch button. And the sketch is now highlighted. So if I wanted to delete this constraint, that's actually this little green button here. So I could click on that constraint. And now it's highlighted in blue. I could delete it using the delete button. And now suddenly I can drag it around again. So again, I'm just going to drag it back in place. We'll talk more about making constraints later. So I wouldn't worry too much about it right now. We're just trying to get a little bit of all the basics going on. So now again, I'm going to exit sketch. And right now, I'm scrolling in and out. That's how you zoom in SolidWorks. And if you hold down the scroll button, you can rotate. So you can see how this is just a square on a flat plane. So the next thing we want to do is we want to extrude the square into a cube. And the way we do that is by using the features. So in your upper left-hand corner on the top toolbar, I'm going to click on Features for the Feature tab. And in the Feature tab, there's a whole bunch of different options for what you can do with a sketch. But the simplest one is an extruded boss or base. And what that's going to do is just going to extrude a sketch in the direction of some vector. So I'm going to go ahead and click on extruded Boston base. And basically, as soon as I click on that, it's going to ask, okay, what sketch do you want to extrude? Because you haven't selected anything yet. So I'm going to go ahead and just come around and click on this one of the lines of our sketch. And bam, now it'll ask us, it'll give us the options to extrude. So I can actually take this little little arrow in the center of our extrusion and just drag that in and out. But kind of like dragging a sketch around, that's not very robust. So in order to actually dimension it firmly, on this left-hand side, there's this little dimension area, and I'm going to again put in 6 inches. So once I do that, I can press on this little green check mark on the left-hand toolbar, and that's going to finalize it. So great, we now have a cube. Can everybody give me a thumbs up once they're there? Fantastic. I don't remember what the other reactions are, but if you are not there, just give me literally any other reaction besides a thumbs up. Okay, so great. So now we made our cube. We're actually going to scrap this now. Actually, let's go ahead and save this and then make a new part. So in order to save a part in SolidWorks, all we have to do is Control-S or File, Save. And I'm going to save this to my desktop. So let's just name this cube. And we're going to save this as a SolidWorks part so we can go and edit back later. Fantastic. So next what we're going to do is we're going to create the top body tube of our rocket. I'm just pulling up our dimensions. Okay, great. So I'm going to go back to our rocket assembly just to show you guys what we're going to be making, so you can kind of visualize it as we go along. So we're going to be making this top body tube. I'm going to open up our part. Okay, so if you notice, this is a hollow tube, and this is going to mimic our how our rocket assembly is, but all we're going to do is make this hollow tube. So again, what we're going to do is we're going to go to New, and we're going to be making a part. So we're going to click on Part. And again, we're now in an empty part file called Part 2. So anytime you're doing CAD with SolidWorks, any other kind of CAD, it's really helpful if you have a drawing to reference before you actually start CADing things. Otherwise, you can get a little lost in your thoughts. It's kind of like writing down a little bit before you start coding, or like writing an outline for writing an essay. So I shared with you guys some drawings, and this is one of the drawings. This is for the top tube. And as you can see, this tube is going to be 30 inches long, 6 inches wide, and have an internal diameter of 5.75 inches, which gives it quarter inch walls. So the way we're going to make this tube, actually, I think this is a great question. Like, Rowan, could you tell me 2 different ways you could make this tube?
Yeah, so here's the really cool thing about CAD is that there's no one way to solve a problem. And the way that you design things has to do a lot with your use case. So like what you want to size out and how you want to build it. So that's something that you can really get used to and learn as you keep going. But when you're designing a tube, there's 2 ways you can do it. You can either sketch an outline of a circle. So basically you sketch a big circle and then a small circle, and then you can just extrude the area in between. Or you can make a big circle, extrude that whole thing, and then make another sketch, make a small circle, and then extrude that out so you can kind of cut away at the smaller inside tube. So those are two main options.
Yeah, so in order to utilize all of the different features of SolidWorks, we're going to do the latter thing what Rowan said. So that means we're going to make a solid cylinder, essentially, and then we're going to cut out the middle of it in order to make a hollow tube. So again, what we're going to do is we're going to start with a sketch. So in our upper toolbar on the left-hand side, I'm going to click on Sketch. And in order to make a new sketch, I'm going to click on the Sketch button. Then we have to select which plane we want to put our sketch on. It doesn't matter, so I'm just going to click on Front Plane. And now we're in sketch mode. Again, the way we know we're in sketch mode is because we have this gray Exit Sketch button up here. So to start us off for making this tube, we're going to be making an extruded cylinder. And again, we're going to be cutting away at the inside of that solid cylinder in order to make our hollow tube. So to do that, I'm going to click on the circle button. So before, what I talked about was constraining your sketch relative to the origin. So instead of drawing our circle or square anywhere, I'm just going to click on the origin to start off. And you can see there's a little yellow square with a coincident constraint there. So I'm going to click on it and just drag our circle out. And now we have a circle that is constrained at the origin. And the way we know there's a constraint is there's this tiny little green box. So right now, if I were to click again, I'd be making another circle, which I don't want to do. I want to constrain the circle. So I'm going to go ahead and press the Escape button. So that way I'm not making another circle. So right now, this circle is just some unknown dimensions. But from our drawings, we know that this tube needs to be 6 inches in its outside diameter. So what we're going to do is, again, we're going to use Smart Dimension. So in the upper toolbar on the upper left-hand side, I'm going to click on Smart Dimension. And if I just hold my mouse over the outside radius of the circle and I click on it, a little smart dimension for the diameter of the circle is going to pop up. In order to place that dimension, I have to click one more time. A little pop-up appears and we can enter our dimension. So that was going to be 6 inches. So I type in 6 and I press the green check mark. And again, if you notice, our circle, which used to have a blue line, is now black. So that means it's fully defined. We can't just accidentally drag this around anymore. So what we're now going to do is we're going to exit the sketch and extrude the circle into a cylinder. So I'm going to go into the upper left-hand side and exit sketch. And now I'm going to zoom out using the scroll button. And you can see how this is just a flat circle on a flat plane. And what we're going to do is we're going to extrude it. So I'm going to click on the Features tab of the upper toolbar. And then we're going to go to Extruded Boss Base. So something in general, when you extrude something, instead of clicking on the Extrude button and then clicking on the sketch, what's much more helpful is if on your left-hand side on the left toolbar, you select the sketch, and then you click on the Extruded Boss and Base. So basically, this pre-selects it. So once I do that, it'll skip the step where I have to select a sketch, and it'll just show us the extrusion option. So from our drawing, we know that this tube has to be 30 inches in length. So on the left-hand bar, where it has the number for dimension, we're going to make this 30 inches long. Press Enter, and it'll have this preview of what it's going to look like. And we're like, OK, that looks right. I'm going to put the check mark. Great. So right now we have a solid tube. If this was a rocket, it would not fly because it would weigh 100 pounds. So we want to make this hollow so we can actually put stuff inside of it. So the way we're going to do that is we're going to put another sketch on one of the faces of the cylinder, and then we're going to cut extrude it. So to do that, we want to put a circle, a sketch on top of this face. And let's just go over some of the other buttons in SolidWorks. So on the top here, you have a whole bunch of buttons. There's this one, which is zoom to fit. So if I'm way out here and I click on zoom to fit, it'll zoom in for us. This is really helpful if you get lost in your CAD sometimes and you can't find it anymore. But the one we really want to use right now is this little box that says view orientation. If I click on view orientation, it's going to zoom us out and it'll bring us normal to one of those faces. So I'm going to go normal, perpendicular to the circular face. Great. So this is really helpful because it's helpful to be facing a plane when you do your sketch. So next what we're going to do is I'm going to click on the Sketch tab on the upper toolbar, click on Sketch. And now when we select what face we want to put our sketch on, we want to click on the top face that we're now facing. Okay. And now what we're going to do is we want to make a circle that we're going to extrude cut through the cylinder. So I'm going to click on the circle button. And now what I want to do is talk about relations. So I'm going to, everybody watch, that you don't need to follow along yet. I'm just going to put my circle out in a random spot. I'm going to press escape to enter the circle mode. So what we really want is we want this circle to be concentric with the outside. That way the walls are uniform thickness all the way through. And the way we're going to do that is I'm going to click on our circle over here. And I want to also click select this outside circle. So the way I'm going to do that is I'm going to hold down Shift while selecting this other outside circle. And what that does is now we have both entities selected. So on our left-hand toolbar, it'll have this little thing that says selected entities, and we can see we have arc 1 and edge 1. So again, to deselect, you can just click anywhere. I'm going to click one edge and then the edge of my other circle. And we're going to add a relation between these two. So we're going to make the relation concentric. So now what you should have is two circles that are one circle that's concentric to the extrusion we already have. Could everybody go ahead and do that, or and then give me a thumbs up if you get there? Can you give me a different reaction if you want me to go over it again, or need more time?
Where does the concentric option come up?
Okay, so the way you do that is you have to first select two entities. So right now, nothing's selected because nothing's over here. So when you select something just by clicking on it.
Mm-hmm.
And the way you select two things so I select one thing by clicking on the edge. So we've selected the circle. And the way we select a second thing is by shift clicking a different object. So I'm going to shift click the edge of the second circle. So there's a bunch of different relations that we can add between these two. We can make it choroidal if we want them to be the exact same size, but we just want them to be concentric.
It almost looks like I'm missing a window, so you have that like.
I know why.
Oh, okay. He knows why. Okay.
It's in the properties notes.
Okay. All right.
Okay, once we're there, we now want to make a dimension for this circle so we know how much to cut out. So when we smart dimension this, we basically have two options. We could just smart dimension this circle, but one of the really powerful things about CAD is that we want our changes to kind of propagate if we go back and change one part of it. So what I mean by that is, let's say you're designing a rocket and you want to use body tubes, these tubes for making your rocket body out of, that have a thick wall thickness of like 1/8 of an inch. If you change your tube size, you want to be able to easily have that change propagate in SolidWorks. So what I mean by that is we could just dimension this circle to be 5.75 inches. And that would work. But what we really want to do is we really want to set the wall thickness. So instead of doing that, I'm going to click on this dimension, press the delete button. We want to dimension the wall thickness. So to do that, I just need to click one circle and then just, again, left click the outside edge. And now you see we have this other dimension pop up, which is the wall thickness. So we're going to make the wall thickness 1/8 of an inch, or 0.125 inches. And once we do that, we can exit our sketch. And now you can see we have our sketch that's on the top of our cylinder. So what we want to do is we want to extrude cut this. Before we were extruding a boss, solid material, and now we want to cut away a material. So in order to do that, I'm going to go click on features. And then instead of doing these boss extrusions, we want to use the cut extrusion buttons. So the way I'm going to do that is I'm going to go ahead and click on sketch 2 to pre-select it. And then we're going to do an extruded cut. So once we do that, you can see how it's pre-selected this and it's giving the option to cut extrude. And in the preview, you can see how that goes all the way through the shape. Before, what we were doing something called a blind extrusion. So there's tons of different extrusion options, and we just want to cut away it all. So instead of doing blind, I'm just going to go click on this little button that says blind, and then select through all. And what's great about this is if I go and change the length of our body tube later, it's still going to cut away at all of the insides. I'm going to go click on check mark. And now we have a hollow tube. Could everybody give me a thumbs up once they're there? Great. So now that we have our top tube, we're going to go ahead and save this so we can use it in our assembly later. So I'm going to go ahead and press Control S, which is going to bring up our save option. And you want to make sure that you're saving this in the same folder. I'm just saving this to my desktop. And we're going to call this top tube.
And just a note, saving it, knowing what folder you're saving it to and paying attention to that is really, really critical when making assemblies. SolidWorks can get really, really finicky if your files aren't where you say they are or if they're not all in the same spot. So whenever you're working on a project, my top recommendation is to make a folder like when you start and then put everything in the exact same folder and don't move it. Because also moving it can break links. So you can move it if you need to, but just know that it might take a little bit of grief to do that. So start organizational skills at the beginning of the project.
Great. So now what we're going to do is we're going to make the nose cone. So I'm going to show you guys that part so you can reference it first. The way you can switch between different files that you have open in SolidWorks is by doing Control Tab. And when I do that, just like tabs in on like an internet browser, I can just select which one. So I'm going to go to our rocket assembly so we can take a look at that. And I'm going to open up the nose cone by right-clicking on it and opening this part up. So you can see what our nose cone is. It's basically this solid piece. And most importantly, you notice how it has this little dip on the edge. And that's so it can slide into our tube. So let's go ahead and make this. I'm going to go and click on New Part. And I'm going to click on the part file. Okay, so before what we were doing is we were doing boss extrusions. So now what we want to do for this nose cone is we want to do a revolved extrusion. So what that means is we're going to be making like a cross section of the nose cone, and then we're going to be revolving that around its center axis. It's really useful for parts like this, where like it's like obviously like has symmetry around a single axis. So the way we do this is the exact same way that we do a regular extrusion. And the way we do that is by clicking on Sketch, clicking on Sketch in the Sketch tab, and then clicking on a plane. And let's go ahead and reference our drawings. So this is what our drawing is. And basically what we want is we want to be drawing, if we can cut this in half, we want to draw the left-hand side of this nose cone, and then we're going to revolve it around its center axis. So what that means is I would have everybody watch and not try and follow quite yet. What I really like to do in SolidWorks is to try and draw everything roughly in the shape I want it to look like before dimensioning it. So I'm not going to worry about how dimensions look yet. But if you notice, as I draw, I start off by clicking on the line button. So line, and then I'm going to start at the origin, so that way we can constrain our part. And if you notice, as I slowly move this line, when I'm 90 degrees, you'll notice that little tiny yellow box pop up. That's a horizontal constraint. So if you notice, when I go vertical, a vertical constraint pops up. So because I want the center axis to be vertical, because it's a little easy to work with things that are 90 degrees, I'm going to snap it to a vertical constraint. So now you'll see this tiny little green box with that vertical constraint. I'm going to make that outside edge of our nose cone. And then I'm going to make the lip. So again, I want the lip to be 90 degrees to the vertical. So you'll see that little yellow box pop up. I'm going to click again. We want the edge of the lip to be vertical. And then I want to complete the cross section of the nose cone by clicking back to the center. And as soon as we have a closed shape, the sketch will become shaded. So you can see this is like the rough shape of our nose cone. So let's have everybody go ahead and do that. And give me a thumbs up once you're good. So once you're here, what we want is, if you notice that this bottom piece isn't horizontal or flat or perpendicular to our vertical. And so the way we're going to make this horizontal is by clicking on it and have this relations tab on the left-hand side pop up. Now we want to make it horizontal, so I'm going to add a horizontal relation by clicking on horizontal. And once you do that, it's going to snap into place, and now it's horizontal. So again, what we're doing is we're making the left-hand side of this nose cone. So you can see how we have the rough shape right now. So the first dimension we're going to add is we're going to add a dimension from the bottom of the lip to the top of the nose cone. And why do we do it like this instead of dimensioning the tip of the nose cone to the base? Is because typically when we design rockets, we design the shape of the nose cone, and then we design how far into the body tube it should go. So you want those to be separate dimensions. So let's go ahead and make this 5 inches. I'm going to click on Smart Dimension. You can click on this point, or this horizontal line. And again, we want to dimension it to the tip of the nose cone. So I'm going to left click on the tip of the nose cone. And now we have a dimension between those two pieces. I'm going to click one more time to set the dimension. And we're going to make this 5 inches tall. And now we have a dimension there. So let's go back to our sketch. So the diameter, outside diameter of our rocket tube is 6 inches, which means that radius is 3 inches. So if I dimension the center line to the outside, we want that to be 3 inches. And what's cool about SolidWorks is you can use formulas. So oftentimes, like, you won't actually have to like do this is a really simple case where you're just dividing by 2. But what we can do is we can put equals 6 over 2. And it'll remember this for us. So now if we ever have to go back and suddenly we have a body tube size that's really weird, let's say it's 7.8956, whatever, and then we do that, we don't have to do that math mentally in our head. Let's just make that 6 over 3. 2. Great. That's kind of like, oh no, now we have this kind of weird shape going on. So in order to fix this, I'm going to exit Smart Dimension. And I'm just going to go ahead and just drag this corner back on the inside. So you can see that you can kind of just drag things around in SolidWorks. And basically, when you make the shape beforehand, you just want to keep that shape in its rough sizing. So what we're going to do is we're going to go back to our drawing.
So sorry, sometimes when I click on a corner when I'm in Smart Dimension, it does stuff, and sometimes it doesn't. Is it a click, hold, and drag? Or?
Yeah, it's a click, hold, and drag.
Okay.
Everything in SolidWorks is a click, hold, and drag.
Okay.
So once we're here, we want to Smart Dimension this side. So this vertical piece is basically how far into the body tube the nose cone will go. So I clicked on Smart Dimension, click on that line, and we're going to make this 1.5 inches deep, which is great. So you can see we're still underdefined, and the way we know that is that there's one blue line here, and in our bottom right-hand corner, it still says underdefined. So the last dimension we need is how long this line is. So all the lines that still can be moved are in blue. So if you notice, I can still drag this line around. So the width of this line is basically the wall thickness of our body tube, which is 1/4 inch. So again, I'm going to click on Smart Dimension, click on this horizontal line. Oops, I selected this midpoint by accident. So to exit that, I'm just going to press Escape. Click on the line. And then we want to make this 1/8 of an inch. Sorry. So yeah, instead of writing 0.125, I can just write in 1/8, and SolidWorks will do the math for us. So once we're here, everything is black. Bottom right-hand corner, it says fully defined, and we're happy. For readability, it can be really helpful if you can drag these dimensions into useful spots. It can be really hard if they're very crowded. So I'm just going to drag these into a way, if I come back later, it'll be really easy to edit. So now I'm going to exit Sketch. So now what we have is this cross-section of our nose cone. And in order to make this into a solid body, we're going to have to revolve it. So I'm going to go to the features on the upper tab, and instead of clicking extruded boss or base, we want to click on revolved boss or base. So what I'm going to do is I'm going to select sketch 1 by clicking on it, so it's highlighted in blue, and then click on revolved boss base. So right now we've selected on it, but it basically does, we need some sort of axis for the sketch to revolve around. So what we want to do is we want to click the center line, and you can see it's highlighted in orange. And if I click on that, we get this preview of our nose cone. I will confirm that by clicking on this green check mark. So if we wanted to make like half of a nose cone, instead of doing 360 degrees, we can make this 180 degrees. And now you can see we have half a nose cone. However, because we're making a rocket, we want a full nose cone. So now what you should have is this nose cone. I'm going to go ahead and save this with Control S. And saving to my desktop. And I'm going to go ahead and name this Rocket Nose Cone. Can everybody give me a thumbs up once they've saved their nose cone file? And interject if they need any assistance. Great. So our last piece is going to be our most complicated one. So it's going to be several steps. So far, we've had just one step for, or two steps in the case of the rocket tube. But we're going to be making this bottom piece. So I'm going to open this file up just to show you guys what it looks like. And there's a lot going on here. You can see in my left-hand toolbar, I did this in 5 different steps. And the way I'm going to show you guys that is I'm going to take this little blue bar and just drag it up. So this is our little time machine. So it shows us the stages of our development. So the first thing we did is we made a solid cylinder. The next thing we did is we added the insert that goes into the top body tube. So the bottom body tube and the top body tube can connect. We then made 1 fin over here. In order to make 3 fins, we then used a pattern, which we'll go into very shortly, in order to copy the geometry. This is really useful, so we don't have to make 3 different fins. We just have to copy it 2 more times. The last thing we're going to do is we're going to finish with our rocket nozzle by using a revolve geometry. So that's a lot, but let's go ahead and create a new part file by clicking on the new button. We're going to click on part. Okay. And we're now in the new part file. So historically, this has been our most difficult part. Please interrupt if you need any help with any part of this. So let's go ahead and just take a look at our dimensions real fast. So on this right-hand side is our full dimensions. So our bottom body tube is 30 inches in length with a 6-inch outside diameter. So that's going to be our first part. So the way we're going to do that is the same way we made it last time, is by doing a sketch on one of our planes and drawing a circle. I'm going to be moving a little faster through this basic sketch part, so please interrupt me if you need any help. So again, I click on the circle button. I click once on the origin to constrain the circle to the origin, and then I click one more time to make our circle. I'm still using the circle tool right now, so I press the escape button to exit out of that, And now what I want to do is dimension our circle using Smart Dimension. So next, I click on the Smart Dimension button. I can click on the outside edge of the circle. Click one more time to create the dimension. And this bottom tube is going to interface with our top body tube, so it's going to have a 6-inch outside diameter. So once we do that, we can exit our sketch. And what we want to do is we want to extrude the circle 30 inches. So I'll click on the features and then extruded boss space.
Ian, what was the diameter again?
The diameter of this is going to be the same as the diameter of our top tube, which is 6 inches.
Okay, thanks.
And we're going to extrude this 30 inches because that's what our drawing says, 30 inches in length. Great. So now we're in the same spot that we were when we made the top tube, which is a solid cylinder, 30 inches long and 6 inches diameter. So I'm going to use zoom to fit to zoom into our part. And now what we want to do is we want to make the insert that extends out. So this way we can connect our bottom body tube with our top bottom body tube. So you can see this insert is 3 inches long and 5.75 inches in diameter. So the way we're going to do that is we're going to extrude boss a circle on the top face of our body tube. So in order to do that, I'm going to click on View Orientation. And I want to click on the face that's normal to the top. And now what we'll see is the top face of the cylinder. So again, I'm going to click on Sketch. I'm going to create a new sketch. So I click on Sketch. It's going to ask us what face or plane we want to make our sketch on. And I'm just going to click on the top face of our cylinder. And now what we want to do is we want to, instead of cut away like we did with the top body tube, we want to extrude out. Same process though. So we're going to click on Circle. And let's go ahead and practice our relations by just drawing a circle somewhere. I'm still using the circle tool. So now I press Escape. And what we want to do again is make this circle concentric to the body tube. So I click on the edge of our sketch circle, and then I shift click on the edge of our body tube. Our selected entities are the two arcs, and we can add the relation concentric. Once we're there, I can click anywhere to deselect all of our objects, and now we have a circle which is concentric with the body tube. So similar to last time, instead of defining the diameter of this, what we really want to do is define the distance between these two circles. So I'm going to click on Smart Dimension, click on the inner circle, and then click on the outside edge of our body tube. And we want the wall thickness to be 1/8 of an inch. So I can just type in 1/8, and SolidWorks does the math for us. And now we have a fully defined sketch because the line is black, and in our bottom right-hand corner, it says fully defined. So if I exit out, we can see that we now have, again, a circle on the top of our body tube. So instead of cutting away this time, we're going to extrude this out. So I'm going to click on Extruded. I'm first going to select Sketch 2. It's going to be highlighted in blue. And then we're going to extrude this. So we want to extrude this 3 inches. And now our two body tubes will connect with each other. Could everybody give me a thumbs up once they're here? Wow, so on it. So again, the next thing we're going to do is we're going to be making our fins. So making fins is tough. It's a little more complicated than we had before. So what we want to do is we want to visualize what planes. So in our left-hand toolbar, we have these three objects, these three planes, front plane, top plane, right plane. And right now they're hidden. And I want to show these. So let's go ahead on, we want one of the planes that cuts our body tube in half. So I'm going to go ahead and click on right click on top plane. And I'm going to click on this little eye so it shows. Because in order to make our fins, we have to sketch on a flat surface. And this body tube obviously doesn't have a flat surface there yet. So we can now draw on this plane. So let's go back and reference our drawings and take a look at our fins. So we can see we have like some trapezoid fins. People are welcome to make other shapes if they wish. But they're going to be 6 inches in length and 3.5 inches in height with a little bit of slant to them. So the way we're going to do that is we're going to do a sketch on this top plane. So I'm going to click on the sketch button. And I already had the top plane selected, so it's going to bring us right into that sketch. So it's really helpful when you're normal to the plane you're sketching on. So I'm going to go ahead and click on View Orientation, and then click on the plane that's normal to the top plane. So we can make our fin. So what's a little tricky right here is that right now, if we were just to make a fin like this, it wouldn't actually connect to our bottom body tube, right? Because as we extruded this out, it wouldn't actually, there'd be a little gap between the fin and the body. So what we're going to do is we're going to cheat a little bit by instead making our fin start on the inside of our body tube. So in order to delete this, I can just drag and select all of it and then press the delete button. There we go. Okay, so again, similar to the nose cone, what we want to do is draw our rough shape. So the way we're going to do that is I'm going to start in this bottom corner of the body tube, draw out here. I'm going to wait until that vertical constraint pops up, signified by that green box. And then I'm going to finish it by connecting it to the face. So next thing is we want our fin to go into the body slightly. So I'm just going to continue by making a little rectangle that goes inside of our body. So now what we have is we have a rectangle shape that's connected to this other rectangle that's merged in the body of the body tube. So if you see right now, this isn't very trapezoidal. So what we want to do is we want to make this line and this top line parallel to each other. And the way we do that is by selecting one of those lines and then shift clicking the other line. Once we do that, on the left-hand toolbar, you'll see line 5 and line 7 pop up, and we can click on the parallel relation. Okay, so that was a lot in one step, but could everybody give me a thumbs up once they get there?
Looks like we're all good. This is going great.
Yeah, that's going really well. So next thing what we want to do is we want to add our constraints to all of this. So what we're going to go ahead and do is we're going to do smart dimension. And again, according to our drawing, you can see that on this fin is supposed to be 6 inches long. So I'm going to click on Smart Dimension. Oops. Right now I have 2 things selected, so it's not going to let me dimension it yet. So I'm going to escape out of that selection and then click on Smart Dimension. And I want to click this vertical line of the fin. And that's going to be 6 inches. Great. Next thing is we want to, how tall the fin is going to be. So I'm going to click the top of the fin and the edge of the body tube. Oops. So right now I made a redundant dimension. Again, I'm going to click on the top and then I'm going to click on the edge of the body tube, and a dimension is going to pop up there. And we're going to make this 3.5 inches. The last thing we need to do to complete the shape of our trapezoid is how slanted it is. So it says 2.75 inches. We're actually going to do something else. We're going to make this an angle. So if I'm still in Smart Dimension mode, I'm going to click on this diagonal line of the fin, and then the edge of the body tube. And now you can see we have an angle constraint really come up. So again, Smart Dimension is really smart, and we'll just try and guess what you're trying to do. So if I click on 2 lines that intersect with each other, that create an angle, it's going to ask what angle we want it to be. So let's go ahead and make that 45 degrees. So the last thing we need to do in order to complete this is just make a dimension for how deep the fin extends into the rocket. So I'm going to click that inside edge and then the outside edge of the body tube. And we can just make this 1 inch. So now we should be fully constrained because all the lines are black. And on our bottom right-hand corner, it says fully defined. I'm going to exit our sketch. And now we can admire our sketch on our rocket body. So right now it's just a sketch. We want to make it 3-dimensional. So the way we're going to do that is by extruding it. So similar to everything else, I'm going to go to the Feature tab. I'm going to pre-select Sketch 3. And then we're going to do an extruded boss base. So if you notice, right now, our fins aren't symmetrical. They basically have an offset. So we want this to extrude equally on both sides of the plane. In order to do that, I'm going to click on this little box over here that says direction 2. So if I click on that, you can now see it's going to extrude in both dimensions. So if we want a fin that's in total a 1/4 inch thick, we want to extrude both of these 1/8 of an inch. So now what we're doing is that we are extruding our sketch in 2 directions, like that, in order to make a fin that's symmetric on the top plane. And then I can press the check mark. What you also want right now is you want to make sure that this merge result checkbox is also checked. That's going to be really important so that this entire thing stays as one part. So now what we have at this point is a single fin on a rocket. So could everybody give me a thumbs up once they're there? And if there's any part which you'd want me to go over again, just let me know. Does anybody need more time? Fantastic.
Looks like
Okay.
that.
So the next thing we're going to do is instead of like copying that thing 3 times over, adding another plane, we can use something in SolidWorks called patterns. And patterns are really useful anytime you're copying something. So because we're copying a fin around a circular object, we want to use a circular pattern. And the way we do that is click on the Features tab, and we're going to go to the button that says Linear Pattern. At the bottom of the linear pattern, there's a little arrow that if I click on it, it's going to give me a whole bunch of other options for patterns. And we want to click on Circular Pattern. So once we're here, there's going to be a couple different options for what we're doing. The first thing we want to do is we want to select what feature we're going to copy. So we want to select the fin. So you want to make sure that this middle intermediate box is highlighted in blue, so we can select what feature. And I'm going to click on the fin that we just made. And it's going to select Boss Extrude 3 for us. The other way you can select it, if you want to clear your selections, you can right-click on that box and click Clear Selections. Is over here, if you click on this little arrow, it's going to bring us back to the, basically it has like a toolbar pop up because right now it's hidden. And then I can also click on Boss Extrude 3 and it'll select that for us. Once we do that, it's going to again basically ask us what center axis this fin is going to be revolved around. And we just want this to be revolved around a tube. So in order to do that, we have to select which direction it is. Under this box, under direction 1, I want to click on that box so we now can select what direction. And we could select we can select any circle, we can select any cylinder, anything which has a center axis. So I can just click on this outside face, and bam, you can see that we have many, many, many fins popping up. So this number of fins is probably overkill for a rocket. We're just going to go with 3 fins. Well, I'm going to go with 3 fins. You can do as many fins as you want. But what we want with a rocket is we want symmetry. So we're going to do equal spacing. The equal spacing over 360 degrees. And then we can do 3 fins. So if I do 3 fins, you can now see we have a preview of a rocket with 3 fins. If we wanted 6 fins, SolidWorks will do that for us. And now we have 6 fins. I'm feeling like a 6-fin rocket today. So I'm going to go do that and then click on the check mark. And once we have that, we should have a bottom body tube with 6 fins. Once you have fins that are circular pattern, could you give me a thumbs up? So this is the part where people usually have the most number of errors, and about half the people fail in this part. So please, if you have any trouble with this, just tell me. Okay, I think we're ready to move on to the basically the last part for this bottom body tube, which is making our rocket nozzle. So the way we're going to do our rocket nozzle is the same way that we did our nose cone, by making a circular extrusion, a revolve. So what we're going to do is we're going to click on the sketch button, and we're going to make a sketch on the same top plane where we made our fins. And I want to go normal to that, so I'm going to click on View Orientation, and then click on the top, and now I will be normal to the top plane. So the exact same way we made our nose cone, we want to make basically a cross section of a 90-degree cross section of the nose cone. Sorry, not the nose cone, the rocket nozzle. So the way I'm going to do that is I'm going to click on line. And it's very important that we start this in the center of our rocket tube, so it revolves around the origin. So you can see the origin is right there. I'm going to wait till it's highlighted yellow. And we're going to start off by making the rough shape of our rocket nozzle, which will kind of flare out like this. So then I'm going to deselect the line. And again, we want this piece. We want that to be flush with the bottom face. So what I'm going to do is I'm just going to click on that bottom line, and we're just going to make it horizontal. So if you notice, that changed the shape of this slightly. So what I'm going to do is I'm just going to readjust it by dragging it out. It's really helpful before you start doing smart dimensions if the piece you're dimensioning is already in the rough shape it's going to be. So now what we're going to do is we're going to reference our drawings again. And you can see that our rocket nozzle is going to be 2.5 inches in height and 4 inches in diameter at its base. So I'm going to zoom into our sketch. And we're going to go to Smart Dimension. And I'm going to make a dimension from the bottom of the nozzle to the top. Again, we're going to make that 2.5 inches. And that's going to bring us there. So what we said was the bottom piece had a diameter of 4 inches. So I'm going to click on the top one. Oops. And we want this to have a diameter of 4 inches, which means we can just do equals 4/2 in order to get the radius of 2 inches. For the bottom piece, the bottom of the nozzle, we're going to give it a dimension of, let's say, 3 inches. So that's going to be equal to 3/2. So now we have a fully dimensioned sketch of what we're going to revolve. So I'm going to rotate around so everybody can see that, and we're going to exit sketch. Great, so everybody should be here now. So to finish this off, we need to revolve this. So I'm going to go to the Features tab, and then select Sketch 4, and then click on Revolved Boss and Base. So once again, it's going to ask us our axis of revolution, and we want to click on the center axis. And now we should get this little yellow preview of our rocket nozzle. So once you do that, that should be your completed bottom half of the rocket. So once I'm there, I'm going to save this with Control S, and I will name this rocket bottom tube. Great. Can everybody give me a thumbs up once they're there? Before we move on to the final part of this, which will be doing the assembly. Okay, is everybody there? Is anybody not there yet? The next part we'll be moving on to assemblies, and that's going to be really different. So I want to make sure that everybody's caught up before we move on. But yeah, so what we've done now is we made 3 parts of our rocket, and now we want to create an assembly out of them to put them all together. So the way we're going to do that is the exact same way we would make a new part, is we're going to click on the new button, and then we're going to click on assembly instead of part. So once we're here, and there's some very small differences between the assembly and the part file. you'll notice that we have some different tabs. When we open a new assembly file, right away, it's going to assume that we want to put some parts in. I'm going to skip this for now, just so I can show you how to put parts in from the beginning. So I'm going to press cancel. So in order to insert parts into our assembly, we want to click on the Insert Components button. So I'm going to click on Insert Components, and then we want to click on we basically want to select our 3 different parts. So what you can do is you can select all of these parts at once. That's what I'm going to do. And we're going to select all 3 of those and then open them. Once we do that, it's going to basically ask us to place it. So in order to place it, I just have to left click. So I put one part down, I put a second part down, and then I put a third part down. And now in our assembly, we should have all 3 of our parts just floating around. And when we can verify that on our left-hand toolbar, we should have 3 objects. Could I get a thumbs up once everybody has all 3 of their parts in the assembly? Great. So in order to actually, I guess the first thing to note about assemblies is once we put parts in them, we can click and drag any part to move it around. And the way we rotate these parts, it's instead of left click and dragging, I right click them and they will rotate the components.
Hey, Ian, what if they can't move the part that has a little F next to it?
So that's a great point. So on our left-hand toolbar, you can see that there's one small difference between these 2 parts. One of them has an F and 2 of them have a dash. So the first part you put into an assembly is always going to be fixed. And we can actually change that by right-clicking our fixed part and then find the float button. So if I do that, I can now move our part around. That being said, it's really helpful to have at least one part of your full assembly being fixed. So I'm going to again right-click the component I want to fix, which in my case is going to be the bottom tube, and I'm going to click on Fix. And now we have a little F pop up again. So our next step is we want to connect these pieces one piece at a time. So what we're going to do first is we're going to connect our top tube to our bottom tube. And the way you connect components in SolidWorks is by using something called mates. So up on the assembly tab of the top toolbar, I click on mate. And it's going to give us a whole different options for what kind of mates we want to do. Similar to Smart Dimension, SolidWorks is really smart about guessing what you want to do. So for example, if I would click the outside face of our top body tube and the outside face of our bottom tube, SolidWorks is going to guess that we want them to be concentric to each other. And we can see that this concentric relation is going to pop up. In order to finalize that, I click on the check mark. I'm going to exit out of mates just to show you guys what that did. So now you can see we have our top body tube as kind of mixed in with it. So before we add our other mates, it's really helpful if they're not like that. So I just dragged it out. So you can see now if I try and drag the top body tube, I can move it up and down, but I can't move it side to side anymore because it's concentric with the bottom body tube. In order to actually connect these 2 components, what we next want to do is we want to connect this bottom face of the bottom body tube and this face of the top body tube using a coincident mate. So the way we do that is by clicking on mate. And once again, we can just select those 2 faces and SolidWorks will kind of guess for us on what we want to do. So if you notice, once I select one component, it's going to go in gray because you can't mate a component to itself. And then I'm going to click on the face. You want to make sure you want to click on the face and not the edge of the top body tube. So once you do that, we're going to have a preview of our connected tubes. So we're so close now. We have now connected our top body tube to the bottom body tube. How's everybody doing with that? How are you doing, Ginny? Did I get a thumbs up from you yet?
I think Ginny had to step out for a little bit, but she might be catching up.
Dang it. I thought I could pick on Ginny. Okay, so in order to complete this, we actually have basically just copied the last steps we did. So again, what we can do is click on mate. And now what we want to do is we want to make our nose cone concentric with our body tubes. So what I'm going to do is I'm going to click on the insert of the nose cone and then click on our body tube. And you'll be like, oh no, where did my nose cone go? It's actually, right now, it's kind of just like hidden in here. So this is actually a great lesson. Sometimes when you do like mates in SolidWorks, parts will just kind of hide. So in order to figure out how to fix this, I'm just going to click through the check marks in order to get there. And on the left-hand toolbar, if I click on rocket nose cone, so I know based on because of this like little dashed line that the nose cone is in there somewhere. But if I want to get it out of there, one thing I can do is I can hide the other features. So I'm going to right-click the bottom tube, and in this top little pop-out, there's a little eye with a cross mark through it, a slash. And if I click on that, it's going to hide it. So now we can see our nose cone again, and I'm just going to drag it out of where the bottom body tube is so we can work with it again. After doing that, on the left-hand toolbar, you'll see that the rocket bottom body tube has a little clear, is clear instead of yellow. So to make it show up again, I'm going to right-click it and click on the eye to show the component. Okay, at this point, you'll be like, oh no, the nose cone is upside down. So what happened there is that it made a concentric mate between the nose cone and the body tube, but it was 180 degrees off. So instead of deleting that mate and doing it over again, we're going to go back in time and edit it. So on the left-hand toolbar, under this little, it's paper clips and mates, if I click on the arrow, it's going to show us all of the mates we've done so far. If I hover over these, it'll highlight the two components which have those mates. So we want to edit the mate concentric 2. So in order to do that, I'm going to right-click on concentric 2, and then click on the edit feature, which is the upper left-hand corner of the pop-up. So if we do that, it's going to bring us back to the mating toolbar. And we can see we have these two faces selected, the concentric constraint. And what we want to do is we want to flip it 180 degrees. So there's this little part that says mate alignment, and we're going to click whatever box is not grayed out. So if I do that, you can see it'll flip around. And now we're going to click the check mark, and great. So in order to finish this, we have one last mate to do. We want to connect this face of the body tube with the lip of the nose cone. So I'm going to click on mates. And what we want to do is we want to click on the face of the lip, and then the top of the body tube. So we'll get a preview of that. I'm going to click on the check mark once more. And once we do that, we should have our rocket. Okay, so could everybody give me a check mark once they have their completed rocket assembly? So we're going to finish off just by doing like one more thing of SolidWorks, which is just appearances. So if you want to actually make it so your model is pretty or looks like how it is in real life, what we want to do is use appearances. So on our right hand, this may be hidden for you, but we want to click on this little appearances bar, which is a sphere with a bunch of different colors. If that's not popping up for you, at the top of your SolidWorks window, there should be that same sphere. If you click on that, this pull-up bar will pop up. So I'm just going to drag this guy out. Okay, so once I do this, there's a whole bunch of different options for what the appearances are. You can make things look like plastic. You can make it look like metal. You can have a lot of fun with it. They have fabric prints. If we were actually making this rocket, we would probably be making out of carbon fiber. So I'm going to go look for the composites. Which I actually don't remember where they are. So instead, we're going to make this just out of metal. So I'm going to make our top nose cone.
Plastics.
What's that?
So you plastics, I think.
Ah, there it is. We have composites. So if I click on composites, in order to apply an appearance to a part, what I need to do is select that part. So I'm going to make the nose cone. I'll click on the nose cone and then double click an appearance. So now you can see that that nose cone has a color now. I'm going to repeat the process for our other two parts using different kinds of carbon fiber. Great, so now our rocket has an appearance, and we're going to finish off by giving it a scene. So in the top of our toolbar, where we also have our magnifying glass and view orientation, on the right-hand circle, where you have a little sphere, a colored sphere with a checkered background, and it highlights to apply scene. If I click on that, I have to click on the tiny little arrow to the right of it. There's a whole bunch of different options, which we can select. And let's put it in Urban Background 5. So there's all sorts of crazy stuff. This isn't that interesting, but let's make it rooftop. You can change the lighting. Sometimes this is useful if you want to ever like make a model for a presentation. Sometimes like I'll import a different background. You might import the night sky to make it a little more realistic, and then you can export this as a file. But once you're here, this is everything that I had planned for this workshop. And that covered a lot of the basics of SolidWorks. SolidWorks has again, a huge ceiling. We only used 3 of the tabs, and I only have a couple of them open right now, but there's tons of different add-ins which you can do to do simulations of strength. You can do simulations of flow if you want to see how air will go through a duct. We do some simulations with our rockets at supersonic speeds to see how laminar the flow of the rocket will be as it goes supersonic. So there's all kinds of really cool stuff you can do. You can do heat studies so you can see how things warm up and how the heat transfers. So SolidWorks can do a lot. It's super powerful.
Awesome. Huge round of applause for Ian and YUAA in general for putting this workshop together. This is a traditional workshop that we've had in the past, and every year they deliver it fantastically. So thank you so much, Ian, for doing this again, probably for the last time since you're a senior. But this is really, really fantastic. And thank you to everybody who joined in. I hope, did everybody get to build a rocket to some extent? Great. Our next step is to make one out of carbon fiber and launch it in the CEID. So look out for that stuff. But as Ian mentioned, there's so many capabilities to SolidWorks, and SolidWorks is not the only program out there. There are other options that as well that you can use outside of Yale. You can use things like Onshape, which is sort of like a cloud-based version of SolidWorks. You can use Fusion 360, Tinkercad even which is a more children's education-based things. You can do motion analysis. Some of these things we'll also cover in a future workshop to do some more advanced stuff. So maybe some of the strength analysis stuff, or even running an engine in real life, or like in SolidWorks virtually. So lots of really great stuff, and hopefully you all got a chance to dive a little bit into this world of CAD. So again, thank you, Ian, and to everybody who participated. We recorded this session, and we'll send it out to everybody who signed up, and just make it available to CEID members in general so they can access it.
And I actually, when I first learned CAD, I learned it online through there's one platform which Yale provides, which used to be called Linda, which is now LinkedIn Learning. They have really, really fantastic tutorials for everything, for Photoshop, Illustrator, SolidWorks, literally every CAD software. It's super expensive normally, but Yale pays for it. And the tutorials are fantastic. That's how I learned. So there's a 3-hour intro to SolidWorks thing, which basically really breaks it down. And it's a great resource for learning different software packages in general. What's really awesome about it is they also update it every single year. So they show all the new features for different SolidWorks versions. So I actually still use it every year so I can learn what new features are included with every SolidWorks release. So I'll add the link to that. I'll send that to Antonio, and then he can distribute that. So.
Yeah, that's such a life hack, LinkedIn Learning. I did not know about it until after I graduated. And luckily I still have a Yale email so you can use it, but definitely use it because there's so much great info that's just out there for free for us. All right, well, everybody have a great night. Jenny, have a good rest of your day. And thank you again, Ian, and everybody else. Good luck with CAD and everything else this year.
Thank you.
Bye, everybody.
Bye.